Bismillahirrahmanirrahim. Today I am going to discuss covalent solid. In previous lecture I discussed with you the properties and structure of ionic solid. So first of all, covalent solids, these are also called as atomic solids, and in their structure there are neutral atoms, while in the crystal lattice of ionic solid there are oppositely charged ion present at the lattice point. First of all, I will discuss some properties of covalent solids. The bonding in the covalent solid is directional. As we see, the BF3 molecule, central atom is linked with fluoride atom through a proper direction, hence the bonding is called as directional. Due to this direction, its structure is open. While there is no proper direction or in ionic solid, we don't represent the ionic bond with line, hence their bonding is non-directional and their structure is called as closed, while the covalent solid had open structure. Covalent solids has low volatility, they are non-conductor even in solid or in liquid state, except graphite. Later in the lecture I will discuss that graphite is conductor along one direction. Mostly these are soluble in organic or non-polar solvent, and generally they are insoluble in water. Diamond and silicon carbide are hard enough that they are even insoluble in any kind of solvent. So before discussing the structure, let us discuss types of covalent solids. There are two types of covalent solids. In one type, covalent, the atoms, they combine to form large giant structure. For example, diamond, silicon carbide, aluminum nitride. While if the atom combine to form lattices or layered structure, then this type is called as layered structure. For example, graphite, cadmium iodide, boron nitride. So first of all, we are going to discuss the structure of covalent solid with respect to the diamond. Diamond is an allotrope of carbon. So in diamond, carbon is sp3 hybridized. If we see the electronic configuration, there are 4 unpaired electrons present. Each carbon undergo sp3 hybridization and hence 4 hybridized orbitals are obtained. It shows that each carbon in diamond is further directly attached to 4 other carbon, and this pattern is repeated in whole diamond crystal. So this type of arrangement is called as tetrahedral. If you see the simple representation of the crystal, that in diamond crystal each carbon is directly attached with 4 other carbon with carbon-carbon bond length 154 picometer and the bond angle is 109.5 degree. If we see the structure, then the overall structure of diamond looks like face-centered cube. So simple representation, look at this carbon atom, it is directly attached with 4 other with tetrahedral manner. So same kind of arrangement is repeated in whole the structure. So overall geometry of diamond is face-centered cube. If we see the structure of graphite, graphite is sp2 hybridized. There is one unhybridized p orbital. So each carbon is further attached with 3 other carbon, and these triangular arrangement of carbon atom, they made layers in graphite crystal. So carbon atom combined to form this hexagon, and these hexagons are arranged in the layer. And this electron, which do not undergo hybridization, this is present between the layer. So these are free electrons are responsible for the conduction of electricity parallel to the layer in one direction. These are not present vertically, so crystal of graphite do not conduct the electricity vertically. So overall structure of graphite is hexagonal. If we see the distance between the layer, these are 340 picometer. If we see the distance between carbon atom, this is 142 picometer. So overall geometry of graphite is hexagonal. This is the structure, properties and types of covalent solid. In next lecture, I will discuss the properties, bonding and structure of metallic solid. Thank you very much.